Good morning. In the last class, we have discussed about the different illustration regarding the phase diagram of water. So today we'll discuss the degree of freedom for each of the curve and each of the area. Let's do one by one. So first we'll calculate the degree of freedom for OA curve. Okay. In the case of OA, here water is being converted from solid state to liquid state. In this point, this is a transition zone. Here, what we are observing, suppose we are giving heat, we are putting some ice inside the beaker, and it is 1 atm pressure. So slowly we are giving heat to the system. Slowly we are giving heat to the system. For instance, now the ice is at minus 10 degree centigrade, and 1 atm pressure. This is minus 10 degree centigrade and 1 atm pressure. Now if I am increasing the heat slowly, then what we are observing, I have put one thermometer here. I am observing temperature, I have kept constant, and we slowly giving heat. This temperature we are observing, the temperature in the thermometer is continuously increasing. But when thermometer reaches 0 degree centigrade, we are observing that now the thermometer is totally stops. There is no increase of temperature in the thermometers. So what happens? But still we are giving heat to the ice at that time. Whatever amount of heat we are giving, it is not increasing the temperature in the thermometers. Rather this heat is being utilized to convert the ice to its corresponding liquid, to its liquid state. So this is called latent heat of fusion. That means at this time, whatever amount of heat we are giving, it is being utilized to convert the phase from solid ice to water liquid. So this is called latent heat of fusion. So this point is the transition point. Here what we are observing in the beaker, in this point water is being converted from solid to liquid. So obviously here in this point water is present in the two phase. One is solid ice, another is liquid water. So here we will write P equal to 2. For instance, you said x. So at x, what will be the degree of freedom? F equal to C minus P plus 2. Components will put 1, phase will put 2 plus 2. So that means 1. Similarly, if we will take the curve OB, in this curve OB, for instance this point, here liquid water is being converted to vapor state. So here also we will observe water in the two state. One is liquid, other is vapor. So similarly the F will be C minus P plus 2, components 1, phase 2 plus 2, 1. So in this case x, the degree of freedom is 1. That means it is dependent upon one variable. In this case, for instance, y, also it is dependent upon one variable. In this case also OC, XY, let's it Z also, the degree of freedom F equal to 1. So in every curve the degree of freedom is 1. And what about the area? For instance, AOC, area AOC. So what will be the phase here? Here water is present only in the solid state. So phase is 1. So F equal to C minus P plus 2, components 1, phase 1 and plus 2. So that means 2. That means in this case the degree of freedom is 2. Similarly, the area AOB, in this case area AOB, the degree of freedom will be 2. Similarly, the BOC, the degree of freedom equal to 2. Degree of freedom is equal to 2. Are you getting my point? Suppose somewhere if we are putting the point, that means we need two parameters, one pressure, one atmosphere, to define the state. But suppose in on the curve some line is put and I know the pressure, then I can extrapolate the curve to get the temperature. So that's the final point, is that in area degree of freedom is 2 2 2, and in the curve the degree of freedom is 1 1 1. And the last point, very important, point O, triple point. What I write? Triple point. What do I write? Triple point at O. Here water is present in three states. One is solid, one is liquid, one is vapor. So here F equal to C minus P plus 2. C minus P plus 2. Components is 1, phase is 3 plus 2. That means it is 0. That means it is 0. That means non-variant. It is not dependent upon any variable. It is not dependent upon any variable. That's why it is non-variant. So these things, for the attainment of triple point, we are not dependent upon any variables. For the achievement of this triple point, we need these two specific conditions, that is 4.5 mm of mercury and 0.0075 degrees centigrade. With these two particular conditions, we can get the triple point where there is the coexistence of water in both solid, liquid and vapor is possible. Okay. And one more thing, we are till now not depicted. This is the OD curve. Suppose here we are some pressure and some temperature. We are increasing the pressure. We are decreasing the pressure and temperature. But in a fast manner. And slowly will enter into this zone along the line OD. In this zone, water should be solid state. But we are decreasing the parameters in such a fast manner that water forgets to become solid. And till now, along the line of OD, it is in the form of liquid and vapor. This is a very temporary condition. This condition is called metastable curve. This is a very temporary condition. If we slightly jerk, give some push to the system, immediately the system will be converted to its original state, that is solid state. Let's take example of the supercooled liquid. This is water. If for instance you will take the minerals, you will take the water bottle, some good brand like Bisleri, Kinley, etc. What will keep in the water in the deep freeze for near about 1 hour, just before the condition of becoming solid. You have to look the experiment very carefully. Just before the solidification, if we will take the water bottle, we will see water is in the form of liquid state, but slightly if we will jerk the water bottle, we will see the water is being converted to solid state. That means when we bring out the water bottle from the ice very slowly, the water was in the supercooled state. That is metastable positions. It should be supposed to be solid, but it was not solid. It's a metastable position. If you slightly jerk the water bottle, it will be converted into solid state. So this metastable curve is a temporary conditions. If we will randomly decrease in a very high speed temperature and pressure, sometimes the liquid forgets to become to go to its to go to a solid state. Rather, it prefers to stay in the liquid and vapor. But whenever, as soon as we are giving some push, agitation, jerk to the system, it will instantly converted into solid state. So this is the OD curve, and it is called metastable curve. Okay.